This problem might seem pretty intimidating at first because it's a six-parter, but fortunately we will be using essentially the exact same process for all six parts of the problem. For the first three parts, we're given three different angles in degrees, and we're asked to convert them into radians. Now essentially this is basically just your standard unit conversion type problem. Degrees are just another unit, and radians are also just another unit. All you really need to know for this problem is that 360 degrees is equal to 2 pi radians. So we can use this conversion factor for any part of this problem. For part A, we have 20 degrees. So we'll just use a basic chain link conversion to convert this from degrees into radians. So we'll set it up like a fraction as we would with a typical chain link conversion. So we put 2 pi radians, we put the unit with radians in the numerator because that's the unit we're converting to, and then we put the degrees in the denominator since that's the unit we're canceling out. So 2 pi radians divided by 360 degrees. So the degrees cancel out and we're left with radians. This gives us an angle of 0.349 radians. And that is our answer to part A. We'll use the exact same process for parts B and C. For part B, we have 50 degrees. We multiply this by 2 pi radians divided by 360 degrees. This gives us an angle of 0.873 radians. For part C, we're given 100 degrees. Again, we multiply by 2 pi radians divided by 360 degrees. And this gives us an angle of 1.75 radians. For parts D, E, and F, we're given three angles in radians, and we want to convert them into degrees. We're going to use the exact same process, chain link conversion and all, only now that conversion factor is going to be flipped, because now we want the radian units to cancel out and be replaced with degree units. So, for part D, we're given an angle of 0.330 radians. So we'll be using the same conversion factor, but now 360 degrees is in the numerator because we're converting 2 degrees, and the angle with radians is in the denominator. So now the radians cancel out, and we're left with degrees, giving us an angle of 18.9 degrees, being our answer to part D. Now we'll use the same process as D for parts E and F. So 2.1 radians is the angle we're given in part E, and we'll multiply this by 360 degrees divided by 2 pi radians. Put this into our calculator, and we get an angle of 120 degrees. Finally, for part F, we're given an angle of 7.7 radians. We multiply this by 360 degrees divided by 2 pi radians. Put this into a calculator, and we find an angle of 441 degrees. And that is our answer for each part of this problem. And that is it for the whole problem. And that's it for this video. I hope this video helped you out. If it did, please consider subscribing, as that'll help me out in making more videos just like this. And if you have a request or a question, leave a comment down below, and I'll do my best to help you out as best as I can. That's all for now, and I hope you all have a lovely day. Bye-bye.